So you've got a camera, and let's be honest, you just leave most of the settings on auto. And people tell you that shooting in manual mode is better, but you don't really know what those numbers at the bottom of the screen mean, and whenever you touch them, you end up making things worse, so you just leave everything on automatic instead. If I'm describing you, then welcome! In this video, my goal is to teach you everything that you need to know about the exposure settings on your camera, assuming no prior knowledge. If, however, you're a professional photographer or videographer who already knows how to shoot in manual mode, then this video probably isn't for you, since I likely won't be covering much that you don't already know. But for everybody else, if you'd like to learn how to use these settings to take better pictures, then stick around. Alright, so let's get started. In order to understand what the settings on your camera do, we first need to talk about exposure, and not the kind that you offer desperate artists instead of payment. Exposure is a measurement of the amount of light which hits the camera sensor or film negative while an image is being taken. If the amount of light hitting the sensor increases, then the exposure goes up, which means that the resulting image will be brighter. And conversely, if less light hits the sensor, then the exposure goes down, and the image will be darker. Pretty simple. Exposure is important because when you or I take a picture, we usually don't want it to turn out too bright or too dark. We want it to be just right, somewhere in the middle. And to achieve this, we need to have the correct exposure. But in the real world, the amount of light in the environment can vary dramatically. For example, let's say that you achieve correct exposure while you're indoors, but then you step outdoors, and you notice that now the image is way too bright, even though the camera settings haven't changed. So this is why it's important to be able to control the amount of light that hits our sensor so we can maintain correct exposure even as the amount of light in the environment varies. And this is where things start to get complicated. See, there are actually multiple settings on a camera which can change the exposure. And depending on which of those levers you pull, you can end up affecting other aspects of the image as well. So it's important to understand what those settings are actually doing under the hood, so you know which setting to change in any given situation. The two main ways to influence the exposure of an image are by controlling the shutter speed and the aperture. Let's start by explaining shutter speed. When a camera captures an image, it exposes the sensor or negative to the light coming through the lens, allows it to collect that light for a few moments, and then stops the collection so the collected data can be read and processed. In some cases, this is achieved using a physical shutter, which blocks the sensor before sliding out of the way to allow light in. This is called a mechanical shutter. And in other cases, such as when capturing video, there is nothing physically blocking the light, and instead the collection is started and stopped electronically. This is called an electronic shutter. Regardless of which method is used, the same general principles apply. The longer the shutter is open, the more time the sensor has to collect light from the lens. And the more light the sensor collects, the brighter the resulting image will be. But when the shutter opens and closes more quickly, the sensor doesn't have as much time to collect light, and the resulting image will be darker. So by adjusting the speed at which the shutter opens and closes, it's possible to change the exposure of the resulting image. However, adjusting the shutter speed doesn't just affect exposure, it also affects motion blur. Motion blur happens when an object moves across the frame while the sensor is collecting light. As the object moves, the light coming off of it will be collected at different locations on the camera sensor. But since all of the light collected will be used to create a single still image, the result will be a static streak of color across the frame. But if, for example, we were to increase the shutter speed so the sensor was open for a shorter period of time, the object wouldn't move so far during the exposure, so the resulting streak would be shorter and more defined. Effectively, increasing the speed of the shutter reduces the amount of motion blur present in the image. But remember, adjusting the shutter speed will also end up changing the exposure of the image. The two are unavoidably linked. So what do we do when we've set the shutter speed where we want it to be in terms of motion blur, but the resulting image is either under or overexposed? Well, in that case, we need to turn to the other setting which influences exposure, the aperture. The aperture of a camera is actually not part of the camera itself at all. Instead, it's part of the lens which attaches to it. Essentially, the aperture is a hole which the light rays travel through before being focused onto the camera sensor. On some lenses, the aperture is a static part of the lens's design, but on others, the aperture is an adjustable diaphragm, which can be open or closed at will. Now, to illustrate what the aperture actually does, let's take a look at the path the light rays follow when they pass through the lens. Let's say we have a camera pointed at some object off in the distance. The light coming off of that object is going to be flying off at arbitrary angles, so if we just point a bare camera sensor at it, then there's no way we'll get any sort of usable image. We need a lens to focus the light so that all of the light coming off a particular part of the object hits a single point on the sensor. So once we place a lens in front of the sensor, we can see that all of the light coming off the top of the object is bent by the glass such that it all arrives at the same point on the sensor. And we can trace paths for any other part of the scene as well to see that they all correspond to their own points on the sensor. But for the sake of simplicity, let's just look at one point to see how the lens affects it. Now let's see what happens when we reduce the size of the aperture by closing down the lens's diaphragm. As we can see, the light is still being focused properly onto the sensor. But some of the light rays which used to have a clear path to the sensor will now hit the diaphragm and reflect back out. So although we're still getting a clear image, there isn't as much light making it to the sensor, so the resulting image will be darker. So we can see that closing down the lens's aperture will reduce the exposure by letting less light into the camera sensor. But like with shutter speed, changing the size of the aperture also has a secondary effect on the image. To see this effect in action, let's take a look at what happens when an object is out of focus. Lenses are only able to perfectly focus light coming from a particular distance away. If an object is too close or too far away, then the light rays coming off of it will come into focus some distance away from the sensor. So the sensor will end up capturing the light as a small circle rather than as a single point. This is called the circle of confusion, and I can almost guarantee that you've seen it before. So here we have an image that is perfectly in focus. You can see everything is clear and sharp. But now, when I throw the image out of focus, you'll notice that those distant points of light there stop looking like points, and they start looking like circles. And that's because the lens is no longer focusing that light onto a single point anymore. And I can't really make out any of those fine details in those parts of the image anymore because it's all just blurring together. And you'll notice that the more I throw the image out of focus, the larger that circle of confusion becomes. But now watch what happens if the size of the aperture changes again. If the aperture gets wider, then the circle of confusion gets larger and the object is even more out of focus than it was before. But notice that this time we didn't actually change the focus of the lens. That first object we were looking at is still perfectly in focus. When the size of the aperture increases, it means that objects which were in focus will stay in focus, but objects which are out of focus will fall even farther out of focus than they were before. This effect is often referred to as the depth of field of an image. While at any given time there is only one infinitely thin plane which will be perfectly in focus, there is also a space on either side of the focal plane which is close enough to being in focus that the image will still look sharp. If the aperture is quite wide, then objects which are out of focus will blur very quickly, so this region will be quite small. But if the aperture is narrow, then objects can be farther from the focal plane before they start to look blurry, so the sharp region will be much deeper. This can have a big effect on the aesthetics of an image. If the depth of field is very deep, then almost the entire image will be in focus simultaneously. But if the depth of field is very shallow, then only the subject will be in focus, and the foreground and background will be blurred out. Which of these aesthetics you like better is entirely up to you, there's no denying that they feel very different from one another. So those are the two main settings which influence the exposure of an image: shutter and aperture. Both of them can be used to control exposure, but they both also have a secondary effect on the aesthetics of the image. So depending on the look you're trying to achieve, you may want to control exposure using the shutter, or you may want to do it using aperture. For example, if you're taking a portrait of someone and you want to really isolate them from the background, then you'll likely want to use a wide aperture to achieve a shallow depth of field, and then adjust the shutter speed until the exposure is correct. Or, if you're a sports or wildlife photographer and want to capture a crisp and detailed image of something that's moving quickly, then you'll probably want to use a fast shutter speed to minimize motion blur, and control the exposure using the aperture. Also, if you happen to be shooting video specifically, then you'll probably want to follow the 180-degree rule. Since video involves capturing the motion of objects over time, our brains typically expect to see some amount of motion blur. If fast-moving objects don't blur very much, then the motion can look sort of choppy and unnatural. But on the other hand, too much motion blur can make things look sort of smeary and hard to make out. So as a general rule, to achieve a normal looking amount of motion blur, the shutter should be open for half the duration of each frame. Or in other words, your shutter speed should be 1 over 2 times your frame rate. I'm shooting this video at roughly 24 frames per second, so to achieve natural motion blur, my shutter speed is set around 1/48th of a second. It's actually 1/50th of a second since my camera doesn't have an option for 1/48, but close enough. Again, this rule is only really applicable to video. For photography, it's a lot more open-ended as to whether the shutter or the aperture should be prioritized. And this concept is likely reflected in the menus of your camera as well. Most professional cameras tend to have 4 main exposure modes: automatic, aperture priority, shutter priority, and manual. In automatic mode, the camera will take control of both the shutter and aperture settings, and it'll basically just guess where they should both be set at any given moment. This mode is the easiest to use, since the camera makes all the decisions for you, but it also offers little control over the aesthetics of the image. In the shutter priority mode, we're able to manually set the shutter speed to be whatever we want it to be, and then the camera will automatically adjust the aperture setting in order to keep the exposure in check. So this is what you want to use if you want to keep the amount of motion blur constant as the ambient light level changes. And then of course we also have aperture priority, where we can set the aperture to be whatever we want it to be, and the camera will control the shutter to compensate. So you'd probably want to use this if you wanted control over the depth of field, but didn't care about the motion blur as much. And lastly, we have the fully manual mode, where the camera gives us control over both the aperture and the shutter settings. So this way we can really dial in our settings to make sure that they don't change without our direct input. But of course, when both of the settings are locked, then the camera can't guarantee that the exposure will be correct. So it's up to us to change the settings if we need to adapt to changes in lighting. Oh yeah, I should probably explain what those numbers representing the aperture and shutter speed actually mean. The shutter speed is usually represented as a fraction, representing the length of time the shutter will be open for. So for example, right now my shutter speed reads 1/50, which means that the shutter will be open for 1/50th of a second on each frame. Pretty simple. But there is another way of representing shutter speed, which is a bit less common because it's only really applicable to the world of video. See, back in the days before electronic shutters, movie cameras needed to have a different kind of shutter than stills cameras. Since a movie camera needed to capture many images in rapid succession and at a controlled rate, it wasn't really practical to have a conventional shutter that lifted up and closed down dozens of times a second. Instead, a rotary disc shutter would be used, which was basically a spinning disc in front of the film negative that had cutouts to expose the film during part of its rotation and cover the film during the rest. The rotation of the shutter would be linked to the frame rate of the camera, so that each frame would be exposed at the right time. This meant that the shutter speed couldn't be changed by adjusting the speed of the disc, since that would put it out of sync with the frame rate. Instead, the duration of the exposure would be altered by changing the proportion of the disc which was open. In the realm of movies, the shutter speed was often represented not as a duration of time, but rather as an angle. The larger the angle cut into the shutter, the longer the shutter would be open. So a 360-degree shutter means the shutter will be open for the entire duration of a frame. A 180-degree shutter means the shutter will be open for half the duration of the frame, and so on. This is why the aforementioned 180-degree rule is called what it is. When the shutter angle is 180 degrees, the motion blur will tend to look most natural. It is possible to convert a shutter angle to a shutter speed or vice versa, but doing so requires knowing the frame rate which the camera is shooting at. And since stills cameras don't really have a frame rate, they've never used shutter angle, whereas a video camera may notate the shutter speed either way. Okay, so that's what the number representing the shutter speed means. But what about this weird F number thing that represents the aperture? Well, that one's a bit trickier. The F number of a lens is calculated by taking the diameter of the entrance pupil and dividing it by the focal length of the lens. If you don't know what either of those things mean, don't worry. All you really need to know is that a lower F number means a wider aperture, and a higher F number means a narrower aperture. Which is counterintuitive, I know, but that's just how it is. And also, these numbers will often come in odd increments, like 1.4, 2.0, 2.8, 4.0, and so on. These numbers are used because each step on this scale corresponds to one stop of light. Now, what's a stop of light? Well, it's a way of measuring differences in exposure. Increasing the exposure by one stop means doubling the amount of light entering the camera, and decreasing by one stop means cutting the amount of light in half. So to use shutter speed as an example, if the exposure time is cut in half, then the amount of light hitting the sensor will be cut in half as well, and the exposure will have decreased by one stop. Now with aperture, this relationship is a bit less intuitive, since reducing the exposure by one stop requires multiplying the F number by 1 over the square root of 2 because math. But honestly, it's probably better to just memorize those one-stop increments that you'll see printed on the sides of lenses. Okay, so at long last, we've covered what the first two settings along the bottom of the camera screen mean. But what about that last one, labeled ISO? Well, it's a very common misconception that the ISO setting on a camera also influences its exposure. It doesn't. Instead, adjusting the ISO setting is a lot like adjusting the gain on something like a speaker. So here I have a sound system that's playing some music here, and you'll notice that when I turn up the gain knob, the music gets louder, even though the actual signal that's going into the receiver is unchanged. In this case, the gain knob is controlling an amplifier that's built into the receiver that boosts the voltage of the signal before it goes out to the speakers themselves. But you might notice also that if I turn up the gain really high, when no sound is playing, then you'll hear this weird hissing, buzzing sound coming out of the speakers. This is noise, because all electronic systems suffer from random noise to some extent, caused by environmental factors. And when these random fluctuations in voltage in the system are translated into sound by the speakers, this buzzing is the result. But why would increasing the gain increase the amount of noise? Well, if the signal entering the system is very strong, then the fluctuations caused by random noise will be very small relative to those caused by the signal we actually care about. So while noise is still present, it's effectively masked by the signal itself and isn't really noticeable. But if the signal coming into the system is very weak, the noise will make up a greater proportion of the output. And when an amplifier is used to boost the intensity of the signal, it also boosts the intensity of the noise. Effectively, the sound gets louder, but the noise gets louder too. And since the noise makes up a greater proportion of the sound, it's much easier to notice. So in most cases, feeding a stronger signal into the system in the first place is better than feeding in a weak signal and boosting it using an amplifier. A stronger signal will overpower the noise and create a cleaner output. And the same principle applies to cameras as well. You may be surprised to hear that even modern digital cameras are still partially analog. The sensor produces an analog signal, which is then digitized and processed by a computer. But in between the sensor and the digitizer, most cameras have an amplifier to boost the signal. And it's this amplifier which the ISO setting controls. Increasing the ISO will boost the signal coming off of the sensor, which will result in a brighter image. But it will also boost the noise as well, and noisier images tend to not look as good compared to clean ones. So instead of increasing the brightness of an image using ISO, it would be better to increase the exposure, the amount of light actually hitting the sensor, to create a stronger signal in the first place. But there are some circumstances in which raising the ISO is the only option. Let's look at one. So right now I have all of the lights turned off, and we can see that the image produced by the camera is very dark. It's underexposed. Now I'd like to increase the exposure, but both my aperture and shutter are pretty much maxed out. An f2.8 aperture is the widest that this particular lens is capable of. And since I'm shooting video, I don't really want to slow down my shutter speed and violate the 180-degree rule. So in this circumstance, ideally I would just turn on some extra lights, but assuming that wasn't an option for whatever reason, all I can really do is increase my ISO. So now with the ISO raised, the image is looking much brighter. But you'll notice that the noise in the image has gotten a lot more noticeable as well. I mean, technically the amount of noise in the image hasn't changed, but increasing the ISO has made the noise much brighter and more pronounced, so it's a lot easier to see. But achieving an acceptable brightness level is worth having a bit of extra noise, so in this situation I've done pretty much the best job that I can. But now watch what happens if I go ahead and give myself more light to work with. Okay, so now the image is way too bright, and I need to bring it back down to the level I was at before. Well, I could choose to bring down the exposure by closing down the aperture. And once I've done that, the image is at a normal brightness level again. However, all of that noise is still present, even though now there's a lot more light to work with. Turning on the light increased the exposure, but closing down the aperture reduced it again by the same amount. So I haven't really benefited from this extra light that I've given myself. Instead, it would be better if I left my aperture where it was at f2.8, but I brought my ISO setting back down closer to where it was at the beginning. This way, my camera's sensor is actually collecting more light, so the signal is stronger, and the amplifier doesn't have to do as much work. And comparing this to how the image looked before, it's clear that the amount of noise has been significantly reduced. So to wrap things up, there are three main ways to keep the brightness of an image in check as the amount of light in a scene changes. The first two, aperture and shutter, will increase or decrease the amount of light hitting the camera sensor. But they'll each also affect another property of the image. Shutter speed affects the amount of motion blur, and aperture controls the depth of field. Which you'll want to adjust in a given situation is up to you, based on your artistic intentions. There's also ISO, which does not impact exposure, but sort of acts like it does at the cost of degrading image quality. So it should be kept as low as possible, and only raised as a matter of last resort. Anyways, I hope you all enjoyed this video. My name is Cayman Crocker, signing off.